June 30th, 1908. It was an ordinary summer morning in the west, endless, desolate Taiga of Siberia. Until the sky split apart and a fireball brighter than the sun blazed across the horizon like the wrath of a god. What followed was an explosion unlike anything ever recorded in history. This blast was so powerful that a forest of 2,000 square kilometers felt as if made of matchsticks. The sound of the explosion was heard from 1,000 kilometers away. The shockwave circled the earth twice. In Europe, nights lit up like daytime. People could read newspaper at midnight. So, what was the source of this enormous force? A meteor? A comet? Or something more exotic, more mysterious? The big problem was this: no one saw exactly what happened, and reaching the site to find answers will take 19 long years. Today, we are trying to solve the mystery of the distant Siberian morning. With the light of modern science, we will reconstruct the blast that shocked the world and ask its most important question. Is this just a mystery of the past or a dark warning about our future? In the early hours of June 30th, 1908, people living across the wide Siberian taiga, even those hundreds of kilometers from the blast center, witnessed one of the strangest moments of their lives. The fireball that appeared in the sky looked, according to most witnesses, like a second sun rising in the middle of the day. Event hunters and Russian settlers in distant villages said they first saw a bright, lush white light coming from the northwest. It was so bright that shadows fell sharply on the ground, and people thought it was a sign from the heavens. A few seconds later, this fireball moved forward with a roar described like a screaming missile. A sound no one at the time could identify, but which we know now was the sonic boom produced by a cosmic object entering the atmosphere at high speed. Then, the sky suddenly turned completely white. A violent flash erupted, and soon after, a massive explosion echoed with a delay. The sound of this explosion was heard from as far as 800 kilometers away. Many witnesses described the sound as first resembling a distant cannon shot, and then a deafening crash directly overhead that shocked the ground. In some areas, the tremor felt like an earthquake. Windows shattered and plaster fell from walls. The most striking part was this: people who didn't even see the explosion were thrown to the ground by the shockwave. Some witnesses said they were sitting on the ground when they felt as if a hidden hand pushed them violently from behind. Houses collapsed, horses panicked, and waves formed in nearby rivers. In summary, on that June 30th morning in Siberia, people saw a fireball brighter than the sun, heard a sonic scream, were shaken by a massive explosion, were thrown to the ground by the shockwave, and no one understood what had happened. And here's the strange part: despite the explosion being so huge, no one was near the center of the event. The Tunguska hunters who lived closest to the area were the nearest witnesses to the blast, and their experience was even more dramatic than modern accounts. On the morning of the explosion, life in the event tents was normal. they first saw a blue-white flash in the sky. Then, almost instantly, a heat wave so intense hit them that it felt hot enough to ignite the tent fabric. Some witnesses describe a hot gust of wine striking their faces as if the door of a furnace had opened. Then everything plunged into chaos with a roar rising from the ground. Trees toppled all at once. Tents were knocked down. Animals scattered in panic. Some events were thrown meters away by the shockwave. According to the account of the tribal leader Shokhan, the sky split in two, and then fire fell. The vine tree it was like the end of the world. In Iran culture, sky-related events are open to supernatural interpretations. So what happened was immediately linked to the anger of spirits. They avoided the Tunguska area for months afterward, calling it Lishkuni, meaning forbidden or cursed land. Some event groups refused for years to guide scientists there, saying a spirit awoke in that place. We fear it will bring misfortune. Event testimonies are among the most valuable first-hand sources showing how violent the Tunguska event truly was. The Tunguska explosion didn't make global headlines immediately because it happened in one of the most remote regions of Siberia. But within a few weeks, Russian telegraph agencies began reporting unusual tremors, strange lights in the sky, and broken windows in distant cities. Then the press became curious. The first reports framed it as the wrath of nature, and early Russian newspaper headlines read, "A massive explosion in Siberia, cause unknown." A fireball appeared in the sky, then the ground shook. Is this divine punishment? Limited scientific understanding at the time added a mystical air to the event. Speculation erupted immediately. In the first weeks, three main theories appeared in the press. First, a massive volcanic eruption. Some newspapers suggested the explosion might herald a new volcano, but since there were no non-active volcanoes in Siberia, this idea didn't last. Second, a meteor may have fallen. Scientists considered this the most likely explanation, but no one had reached the site to investigate. Third, a divine warning or apocalyptic sign. In rural Russia especially, people describe the event as the sky tearing open, heaven's anger. European newspapers were more cautious. London and Paris papers described it under headlines like an extraordinary atmospheric event. They discussed the meteor possibility, but they lacked scientific data. Soon after the event, a Kazakh postal inspector named Semyon Lavrov passed through the region and produced one of the earliest important field reports. While traveling through the Taiga, Lavrov noted he saw the flash of a massive explosion. Some areas of forest were flattened. He spotted burn marks on the ground. When he sent these observations to the authorities, the report gained significant traction in the Russian press and drew the first serious scientific attention to Tunguska. Lavrov was among the earliest officials to approach the area. His reports spread the first confirmed information that the region truly was devastated. It became the spark that eventually led to Kulik's expedition in 1927. Before discussing Kulik's research, let's first examine the causes behind the 19-year delay. Russia in 1908 was still emerging from turmoil after the 1905 revolution. It was Siberian lands were difficult to control. Scientific funding was extremely limited. Even military units assigned to map the region were insufficient. So even if people knew an explosion had occurred, no one was in a position to say, let's go investigate. Reaching the area was nearly impossible. Traveling to Tunguska meant no trains, no roads, swamps in the warm season, -60 sea winters, unbelievable insect swarms in summer, sudden river flows. The region was essentially inaccessible. Between 1908 and 1910, a few hunters and settlers approached the area, but they weren't scientists. Their reports lacked detail, and the Russian administration didn't prioritize them. In short, no one seriously considered sending a scientific team, and when they finally did, war broke out. Russian scientists were preparing an expedition in 1914, then World War I erupted, and the plan was shelved. Then came the Russian Civil War between 1917 and 1922, with the entire country in chaos. A heavenly explosion in Siberia could not possibly be a priority. The reason Tunguska's mystery remained unsolved for 19 years can be summarized in one sentence each. The explosion occurred in one of the world's most inaccessible regions. Reaching the area was nearly impossible. Russia was in political turmoil. There was no funding for scenes. Local events refused to guide researchers. Wars delayed exploration. Result, one of the largest explosions in world history was nearly forgotten for years. We say forgotten because Leonid Alexeyevich Kulik wasn't assigned. He volunteered through sheer curiosity and persistence. Kulik, a meteor science specialist working at the Geological Museum in St. Petersburg, became obsessed with the event when strange rumors of a Siberian explosion circulated in scientific circles in the 1910s. In the 1920s, the Soviet government was interested in the economic value of the rare metals in meteors. Kulik seized the opportunity and told officials, let me go to Tunguska. If it wasn't an iron meteor, we might find valuable iron nickel. The Soviets liked this idea because it promised economic benefit. Thus, Kulik was granted an official exploration permit. Without him, the event might have remained unexamined for many more years. Kulik and his team set out for the blast site in 1927. This journey was far more difficult than modern documentaries imply. First, reaching the area was nearly impossible. They couldn't go near the blast center by train. Kulik's team first traveled by train to Perm, then continued by a horse-drawn sled, then switched to reindeer-pulled sleds in the Taiga, and covered the blast part on foot. In some swampy areas, the ground was so soft that the team had to use hollow tree trunks as walking platforms. Second, resistance from the Evenks people. The journey's difficulty wasn't only physical. Kulik needed Ivan guides, but they still considered Tunguska a cursed and forbidden place. Many refused to take him. Some agreed for payment, but still avoided certain areas. Third, deadly climate conditions. As mentioned earlier, the region was extremely harsh. Summer swamps, claws of mosquitoes and flies, sudden rainstorms and river floods, freezing cold at night. Conditions were so bad that some team members wanted to turn back. Fourth, shortages of supplies and food. Perhaps the hardest part. The Soviet budget was limited. Kulik lacked proper maps, enough food, and adequate camping equipment. Some days, the team survived only on fish and small animals they hunted. But despite all the difficulties, Kulik finally reached the mysterious area no one had entered for 19 years, and what he saw shocked him even more. What Kulik expected to find was simple: a huge crater and giant meteor fragments scattered around. But the reality was completely different. What appeared before Kulik became one of the most iconic images in scientific history. Tens of thousands of trees were laid out underground in circles, expanding outward from the center of the blast. But at the very center, the trees were still standing. These upright, branchless, scorched trunks were what Kulik famously called telegraph poles. That's what had been left behind. Why did Kulik call them that? All their branches had been blown off, leaving only tall bare trunks. No leaves, no branches, no tops. They all leaned or broke in the same direction. The outer rings of trees were completely flattened, while those in the center stood upright and straight. The scene resembled the burnt poles left at the center of a bombing. This pattern of destruction taught Kulik one thing: the explosion had occurred in the air. If a stone or metal meteor had struck to the ground, there would be a massive crater. The central trees would have been obliterated, and the shock pattern would be directed inward. But in Tunguska, the central trees were standing with their trunks burned, indicating a shock wave that had come from above. Kulik was fascinated when he saw this scene, but at the same time he wondered in shock. If the explosion was this huge, where is the meteor? Kulik's Telegraph Fall forest was one of the earliest clues that Tunguska had exploded in the atmosphere, but in 1927 there was still not enough data to prove it. Nevertheless, they did find certain things. They discovered burn marks on the surface soil and physical changes indicating exposure to high temperatures. After his first expedition in 1927, Kulik was determined to solve the mystery of the region. For that reason, he organized multiple follow-up expeditions in 1928, 1929, and 1930. Each time, he documented extremely important data. Yet, the picture he encountered during these missions only made Tunguska even more complex. Kulik and his team mapped hundreds of thousands of trees knocked down outward from a single point. This was strong evidence that the explosion had occurred in the sky at a specific focal point. Years later, these maps would be used by modern science as the exact location of the blast center. It was also determined that trees near the explosion zone had their outer bark completely burned, while the inner wood remained standing. This pointed to a very strong but short-lived heat wave, a classic sign of an atmospheric airburst. They also discovered round ponds in some swampy areas. They investigated whether these were formed by a meteor impact, but none showed signs of shock effects or heat-related melting. So, they were not impact craters. Still, Kulik had the bottoms of these pits dug out in case meteor fragments had fallen there. But nowhere did they find any significant metallic meteorite pieces. This seriously puzzled scientists of that era. But Kulik insisted on searching for a crater because the giant fireball had been recorded in the sky in 1908. The idea that such a large celestial object could disappear without leaving a crater seemed illogical at the time. Today's airburst theory developed only in the 1950s to 1960s. In Kulik in time, the dominant scientific belief was meteors hit the ground. So Kulik focused entirely on looking for a crater. The flattening of 2,150 kilometers of forest, according to Kulik, meant that the large object had struck to the ground at high speed. The idea that such immense damage could be caused without touching the ground, solely through an atmospheric explosion, simply did not make sense to anyone back then. After Kulik's death, Tunguska research slowed for a long time. But starting in the 1950s, especially during the Cold War, the scientific world took renewed interest. Thanks to nuclear tests, scientists now understood shockwaves, mushroom clouds, and thermal radiation in the atmosphere far better. This new knowledge helped solve the Tunguska puzzle. In the 1950s to 60s, Soviet scientists, especially Zolotov, Forensky, and Fast, returned to the region to re-examine tree-ring damage to soil's thermal effects, directional fall patterns, and the radial destruction zone. The result was crystal clear. The explosion occurred in the sky, not on the ground. There was no crater, as Kulik had searched for, because the object disintegrated before reaching the surface. Calculations showed that the meteor had a diameter of 30 to 50 meters, entered the atmosphere at about 20 kilometers per second, and broke apart under intense pressure at an altitude of 5 to 10 kilometers. The energy released during this breakup reached 10 to 15 megatons, at least 300 times more powerful than the Hiroshima bomb. Along with computer modeling, scientists uncovered not only the strength of the blast but also solved the tree mystery that had gone unanswered since 1927. The fireball in the sky left trees standing upright near the center because the shockwave moved downward. Meanwhile, the outer 30-kilometer zone was flattened radially. From the 1950s onward, scientists began systematically collecting soil, peat, and swamp sediments from Tunguska. These samples, especially under microscopic analysis, provided crucial evidence. They increased our understanding of what the object could and could not have been. Microscopic spherules, tiny glass-like spherical particles, were found in soil samples, only a fraction of a millimeter across. These spherules had melted and solidified under high temperatures and contained iron, nickel, silicon, and magnesium, structures extremely unlikely to form naturally on Earth. They strongly indicated that a cosmic object had burned up and fragmented in the atmosphere. Another type of particle found was silicate-rich fragments pointing to rock-like material inside in the object. In short, the Tunguska body was not a purely metallic meteorite. It contained rocky components as well. This weakened the iron meteor hypothesis. There were no large iron-nickel pieces in the soil. No crater, and iron meteorites normally reach the ground intact. Tunguska was the opposite case. Therefore, a stony meteorite became the most likely explanation. Because the silicate metal mixed in the microscopic particles matched stony meteorites well. These are more fragile and much more likely to produce NA bars. Still, the comet hypothesis is not entirely dismissed. Comets consist largely of ice and dust. They contain little metal and therefore break apart in the air very easily. For these reasons, some scientists argue that Tunguska may have been an icy, loosely structured comet nucleus. This site increased water vapor concentration and ozone changes in the atmosphere as supporting evidence. But the presence of microscopic metal and silicate particles proves the object was not made entirely of ice. Now, Let's look at some of the more extreme theories proposed over the years. First, Nikola Tesla's Dutch ray theory. This is one of the most popular conspiracy theories. Tesla was working on the Cliff Tower, his wireless energy tower, in 1908. Some claimed he accidentally directed a powerful energy beam towards Siberia. His statements about transmitting energy long distances fueled the rumors. There is no scientific basis for this, but it remains one of the most circulated theories in pop culture. Second, antimatter explosion. Some theorists suggested that antimatter particles struck Tunguska. When antimatter meets matter, both convert entirely into energy, which at first glance sounds compatible with a giant explosion. But antimatter cannot exist naturally in microscopic amounts, and the radiation signature would be unique. Let's clarify antimatter simply and correctly. Every particle in the universe has an opposite twin, an antiparticle. Electron, positron. Proton, antiproton. Neutron, antineutron. These form antimatter, which looks identical and has the same mass but opposite electric charge. When matter and antimatter touch, they annihilate, releasing enormous energy, thanks to E equals Mach 2. This is why some thought maybe antimatter exploded over Tunguska. But this is impossible. Annihilation produces instinctive gamma rays. No such radiation signature exists at Tunguska, and antimatter only existed in microscopic amounts, produced in places like CERN, billions of a gram. Third, a micro black hole. Another popular but unscientific idea claimed that tiny black hole passed through Earth, causing the explosion as it entered and exited the planet. Discussed in the 1970s to 80s, but entirely hypothetical. Fourth, alien spacecraft, nuclear engine failure. One of the most famous pop culture explanations. A UFO's reactor exploded, or the craft detonated upon entering the atmosphere. Some even claimed aliens destroyed a meteor to protect Earth. No scientific support, but widely shared online. Fifth, natural gas explosion, geological event. Some early theories claimed methane gas pockets in Siberian swamps exploded, or that volcanic activity was involved. But the energy release and threefold pattern do not match these scenarios. Thanks to its mysterious nature, Tunguska has inspired countless theories for over a century, both in science and in popular culture, but most have been ruled out through scientific investigation. Another scientifically important aspect is nature's recovery speed. Today, the Tunguska region is surprisingly calm, quiet, and covered with regrown forest. While microscopic traces of the blast remain, nature has healed almost everything. About 80 million trees were burned or knocked down in the explosion. But the taiga is a powerful ecosystem, and within 20 to 30 years, the first conifers began returning. By the 1950s, most of the region had recovered. Nearly all trees visible today are the same age, a biological clock confirming the timing of the event. The forest essentially rebuilt itself from zero. The area remains harsh, swampy, densely forested, and sparsely inhabited. No settlements, no roads. Only area where scientists or tourists can camp. Visible signs of the blast remain within a 3 to 5 kilometer radius of the peak center. The circular pattern of fallen trees is still detectable in the terrain. In some spots, old burn layers can still be found underground, and the butterfly-shaped destruction pattern radiating outward is still clearly mapped. There are even memorial spots, such as Kulik's historic 1920s to 30s campsite. So, could Tunguska be a message for us? We still cannot track small Earth approaching objects well enough, and we do not know where the next Tunguska scale event might occur. Imagine an 8 to 12 kilometer altitude airbus of 10 megatons above a major city, Istanbul, London, New York. Let's lay out the consequences clearly and realistically. First, Shockwave. The city is flattened. 30 kilometers of total destruction. Heavy damage within 60 kilometers. Windows shattering up to 30 kilometers away. Tunguska flattened 2,000 kilometers of forest. In a modern city, that means millions of buildings. Second, pressure and wind speed. 300 to 500 kilometers per hour wind wall. Skyscraper frames collapse. Bridges fail. Even reinforced concrete structures crack internally. Third, extreme heat and fireball. Even without reaching the ground, the fireball in the air reaches thousands of degrees. Massive armor and forest fires in it. Severe burns, retinal damage for anyone looking at the flash. Fourth, infrastructure collapse. Power grids fail, cell networks disappear, water pipelines burst. Most hospitals collapse, reducing emergency response to near zero. Fifth, casualties. Depending on the city's density, 1 to 3 million deaths, 5 to 10 million severe injuries. This exists on modern wars. It sounds apocalyptic. For decades, Tunguska was seen as a strange natural incident. But just like the scenario we built, by the late 20th century, scientists realized what a massive threat such events pose. For the first time in history, humanity is actively trying to defend itself from space-borne dangers. Let's look at how. First, near-Earth object tracking programs, NEO tracking. NEOs are objects that pass close to Earth. Since the 1990s, telescopes in the US, Europe, and Japan have been scanning the sky. The goals: detect approaching rocks, ice bodies, calculate their orbits, identify dangerous objects years in advance. So far, more than 36,000 NEOs have been identified. Over 1,000 are tracked as potentially hazardous asteroids, PHA. Yet, most Tunguska-sized objects, 50 to 100 meters, remain invisible. That's why the next steps were developed. Second, NASA's DART mission, humanity's first asteroid deflection test. DART made history in 2022. How? It intentionally crashed into an asteroid named Dimorphos, which is 160 meters in size, and the collision changed the asteroid's orbit by several minutes. So technically, humanity altered the trajectory of a space rock for the first time. This is the first proof of a strategy that could be used in the future if an asteroid heads toward Earth. The object that caused Tunguska was 60 to 80 meters. Dimorphos, on the other hand, is a 160-meter asteroid. So the type of object DART can deflect is far more dangerous than the one that caused Tunguska. Early warning satellites and new systems. NEOWISE. Active since 2010, it scans space and detects heat-emitting asteroids extremely well with its infrared cameras. Fly-Eye Telescopes (ESA). With its compound insect eye-style multi-lens system, this telescope is Europe's asteroid early warning project. Sentinel and NEO-Surveyor upcoming. NASA's asteroid radar satellite, planned for launch in 2027. It will focus specifically on detecting small Tunguska-type objects. Even with all this data and all the precautions, there are still unanswered questions. Even if assumptions are accepted, what was it? Where did it come from? How exactly did it explode? What was its true power? Why are there no large fragments? Will we be able to detect it the next time? These questions still cannot be answered clearly. All we can estimate is how destructive the outcome would be if the force that flattened Siberia's remote forests that day were to explode over the city today. Maybe the biggest lesson Tunguska left us is how silent yet incredibly dangerous the universe can be. Even a tiny piece of rock orbiting in space has the power to challenge our entire civilization. That's why the monitoring systems, early warning projects, and planetary defense initiatives humanity is developing today are not just technological necessities. They are existential obligations. Tunguska's mystery may never be fully solved, but what it reminds us is very clear. The sky is not just a view we look at. It is also a warning sign that shapes our future. Let's meet in the comments. And please don't forget to support the channel by subscribing and turning on notifications bell. Take care.
A stark reminder of the fragile nature of our existence. The century closed with a blast that echoed across the globe.